Once again, you're welcome to Waidsum Academy. Today we're looking at additional mathematics, chapter 4, factors are polynomials. Okay, factors are polynomials. Here, we are supposed to quickly have an overview on the use of a reminder factor theorems. And then we also need to quickly get abreast with the how to find factors of polynomials, and also to solve cubic equations. So these are the three big objectives for this chapter. And here are some quick reminders, things you need to know about polynomial. Factors are polynomial. So a polynomial is an expression of the form, a substrate n, x raised to power n, plus a substrate n minus 1, x raised to power n minus 1, plus a substrate n minus 2, x raised to power n minus 2, plus meaning continue a n substrate n minus 3, x raised to power n minus 3, continue in that manner to a2, x2, a1, x1, and plus a. So a2, a substrate 2, x raised to power 2, a substrate 1, x raised to power 1, plus a naught, okay? Okay, so this is the form of polynomial. This is how we write a polynomial. And we're going to see that where x is the variable, x is what? The variable, and n is a non-negative integer. N is a non-negative integer. And then the coefficient of this polynomial are an. Coefficients are an. These are the coefficients, okay? Then the constants are the what? A0, right? A2, A2, A0. Okay. Now, an is the leading coefficient. An is the leading coefficient. A substrate n is called the leading coefficient because it's the first one and is the highest one. Okay, and it must not be equal to 0. A naught is called the constant. We've already mentioned that. A naught is called the constant. Now let's take a look at examples. Adding and subtracting and multiplying polynomials. Let's start with addition, subtraction, and multiplication of polynomials. Okay, polynomials, like we said, can be anything to power anything down to a constant. So let's assume px, the first polynomial, is 3x to the power of 3 plus 2x to the power of 2 minus 1. This is the first polynomial, we call it px. And the second polynomial, qx, is x to the power of 3, 5x plus 3. This is the second polynomial, qx. Find an expression for px plus qx, which is easy, you know. Normal mathematics, we are asking you to add this polynomial to this polynomial. We are asking you to add the px plus qx. That's the first question. The second question says you should subtract 2qx minus, take it away from px. The third one says you should multiply px and qx. So in any case, the first one is addition, the second one is subtraction. It's addition of polynomial. Let's start with the first one, which is the addition of polynomials. Okay? Px plus qx, because they say we should add, plus what? Qx. What's qx? X to the power of 3 plus 5x plus 3. Now, we add. We only add the one with the same power, okay? So when we want to add, we have to add the one with the same power. We have to add the one with same power. What do we mean by that? You're going to add, this one has power 3, right? This one also has power 3. So we're going to add this and this together. We're going to add this to this. Meaning we have 3x to the power of 3 plus x to the power of 3. It's like you say 3 oranges. Let's assume x to the power of 3 is orange. So here you have 3 oranges. Here you have just x to the power of 3 means 1 orange. In math, there's one hidden one here we don't write. it means 1x to the power of 3. So 3x to the power of 3 plus 1x to the power of 3, you get 4x to the power of 3. That's how we got this 4x to the power of 3. That's how we got this 4x to the power of 3. Then you look at this one. It doesn't have, this one is power 1. It doesn't have power 2. But this one is power 2. So you cannot add this to this. You cannot to the power of 2. You don't add it to 5x because they don't have same power. Then here, over here, there is no x to the power of 1. Only here we have it. 5x to the power of 1. So you write it only like that. 5x to the power of 1. Then you have minus 2, constant. This is a constant. This is also a constant. Minus this polynomial. It's like we just collected like terms. That's what we did. We just collected like terms. Okay, we collected like terms. Power to power. Same power, you add to same power. Okay, you don't add polynomials that do not have same x power. Okay? Okay, so that's for the first one, which is the additional. Let's go to the subtraction. Because if there's negative, the negative outside here will affect everything inside this circle bracket. So the reason why we put bracket, the signs can change the sign inside. So that's why we put bracket to make it clearer. Negative 6. So you've expanded this. This one, you just write them out the way it is. 3s squared plus 2s squared. 3s cubed plus 2s squared minus 1. Then minus 2s squared minus 10x. Now you collect like terms. After you reach this level, we collect like terms. Now it means deal with them together. Same power, you deal with them together. This one and this one, and all the way to this one. Write it. Nobody is going to penalize you, but it's just that it does it. It's just like you say orange. No need to say one orange. Just say orange. We already know it's just one orange. Okay, or an orange. No need to say one orange. Okay. You get 15x to the power of 4. Why power 4? Because x to the power of 4. Remember, ordinary x means x to the power of 1. Ordinary x means what? S to the power of 1. Ordinary x with multiplying this and this now. So you get 15x to the power of 4. Why? Because x to the power of 3 multiplied by x to the power of 1. In indices, you write x and you add the power. 3 is here, 1 is here. This power is 1 even though we don't write it. So you get 15x to the power of 4. Then you take 3s to the power of 3 times 3. That one will just give you 9x to the power of 3. And then we move to this one. 2s squared. 2s squared times s to the power of 3. You get 2x to the power of 5. Then 2s squared times 5x will give us this 6s squared. Right? Will give us this 6s squared. Then we are done expanding this bracket. Using this to multiply everything inside this bracket. We go to the last phase, which is using the constant to multiply everything in the bracket. Minus 1 times x to the power of 3, you get minus x to the power of 3. This one will just change everything to negative. That's it. Minus 1 times 5x will become minus 5x. Minus 1 times there's no any other one with power 6. So you just write 3x to the power of 6 in this one, power 6. 3x to the power of 6. Right? Then power 4, there's power 5. We saw power 5 today, yeah. 2x4, and it's the only one. So you have to arrange sequentially from 6 downwards, okay? Then after power 5 is power 4. We had plus 15x to the power of 4. After power 4, I think we had power 3. Power 3, we had 9 to the power of 3. Okay, there are 3 terms. So 9 to the power of 3 plus 10 to the power of 3, that's already 19 to the power of 3. Then minus power 3, that you get 18. So you get 80. That's how we got. Meaning we are adding this one. We are adding this one. We are adding this one. Power 3. Let's look for the power 3. This one. Oh, sorry for cancelling out. I thought the highlighter was taking. Okay. Okay, let's say power 3, this one. this one, 9x to the power of 3 plus 10x to the power of 3. That's 19x to the power of 3 minus x to the power of 3. You get 18x to the power of 3. That's how we got this 18x to the power of 3, this one. Okay? Now let's see power 2. Which one is available for power 2? Power 2, let's see, 6x to the power of 2, right? We see 6x to the power of 2. Is there any other power 2? No, right? So we write only that one down. 6x to the power of 2. Then power 1, I know we have 5x. We have minus 5x to the power of 1. Is there any other power 1? You have to check. No, right? So you write minus 5x. Okay, you don't have to write power 1, just say minus 5x. Then for the constant, we have negative 3 here. Check if there's any other constant. No. So you say minus 3. So that's the end. So you've multiplied this polynomial. You get 3x to the power of 6 plus 2x to the power of x minus 3. So this is the polynomial, the multiplication of these two polynomials. This is the multiplication of these two polynomials. So this is the first section for chapter 4.1. Every exercise problem will either be addition or subtraction. First they will give you scalar multiplication, then you subtract, and then multiplication. So I want you to pause this video and solve these following questions, all of them. This is multiplication. This one, you're going to use this one to multiply all of this, and then you take minus 1 also to multiply all of this, and then you collect like things. This one, you first of all expand. This one is in Cambridge Igcse. This one, you expand these two first. You expand these two. Whatever you get, you square. The answer you get, you double it, and then you expand again second time. Okay, this one, you write this one twice with a bracket, and then you use the second one to multiply, just like the example we did just now to expand this first one. So this one, you expand this one. The answer you get, you use to multiply this one. This one, you write it twice, 3 times. You expand the first two, then the answer you get, you use to expand the third one. So these are one. And then you had this. It says find the expression for PS plus, just like with the example we did. PS plus QS. So meaning you add this polynomial to this polynomial, addition. So you pause, you expand, and you multiply. Solve as many questions as possible. If you're refusing to solve, no one can help you. If you're refusing to solve problems, no one can help you. No one, even the best brain in the world cannot help you. Because the best brain is his brain. He's teaching you what he knows, right? After someone has taught you and you've understood, the next step is for you to teach yourself, like to solve the question and master it. Mastering the skills is your business. Getting the knowledge is your tutor's business or your teacher's business, okay? Now we move to the second section, which is 4.2. Today we are taking 2 sections. Every part of the video will be taken to 2 sections. Division of polynomial, okay? This one I think we'll just do one example because division is similar. After one example, you pause the video and do the polynomial. So you're going to do a long division, what they call long division. Okay, but it's easy. I will show you. So you say s to the power of 3 minus s squared minus 5x minus 3 divide by, divide this one by this, by s minus 3 only. Okay, this small, okay, s to the power of 3 divided by s, you get what? S to the power of 2. You'll be writing your answer on top. You get what? S to the power of 2. Okay, you get s to the power of 2. You write the answer on top. S to the power of 2. Meaning s to the power of 3 is s 3 times. Cancel 1 times x. This is the meaning of x to the power of 3. Meaning s is multiplied 3 times. Divide by x means you do over x. So 1x will cancel 1x. What remains now? Is it not s to the power of 2? Only 2 remain here, x to the power of 2. You don't need calculator for additional maths. Okay? It's a non-calculator mathematics. So x to the power of 3 divided by x, you get what? X to the power of 2. You write it out. You write the answer out. That's how we get this. Let's change the color. So this. So you get x to the power of 2. Now that x to the power of 2 that you got, use it to multiply everything outside here. Use it to multiply. Remember, the only answer you have now is only this. These ones you've not reached there. You've not seen them. It's not there yet. You only had s to the power of 2. Take this s to the power of 2 times x. You get x to the power of 3. Write it under this. Write it under this. Say x to the power of 2 times x. You get s to the power of 3. There we draw a line. We say subtract. Subtract means you write negative here. Meaning everything here minus this one. This one minus this, you get 0. That's why they did write anything. Okay? So this minus this, you get 0. Now this minus x squared minus 3x. So minus minus will become what now? Because this minus, this minus. There's this minus. Okay, if you like, you can put bracket here to show that this minus is talking to this negative also. Negative makes this one to be plus. So it's like you have minus s squared, like this minus 1s squared. It's like you have minus 1 orange. Like you're owing someone 1 orange. Let's say assume s squared is orange. Okay? Minus 1 orange plus 3 orange. What you have? You have 2 oranges. You have 2 oranges. Minus s squared plus, why is it plus? Minus minus. This minus and this minus makes this one to be plus. It's plus 3s squared. Minus s squared plus 3s squared, you get 2s squared. That's how we got 2s squared here. Okay? When you reach here, you bring this one down to it. You bring this one down to join this. You know we only have this one now. You bring this one down to it. You bring this one down to it. To have your complete polynomial, the remaining part of your polynomial. So you now have 2s squared minus 5s minus 3. This is what you have now. We want to divide this again, like what we did here when we started. We want to divide this with what? With x only. With x only. So you say 2x squared divided by x. 2x squared divided by x. It's like 2x squared, 1s, we cancel 1x. It will remain only 2x, right? 2x squared divided by x, I will get 2x. That's how we go. Every of your answer, you are writing on. Divide by x. When you divide by x, it's like this x, we cancel this x. What remains is 2x. Well, 2 times x is 2x. That's how we got this 2x. That's how we got this 2x. Now you, okay, so 2x times x, I'll get what? I'll get 2x squared. 2x times x, I'll get 2x squared. So I'll write it under this. I'll write it, so I get 2x squared. I'll take this 2x times negative 3. I'll get negative 6x. So I write it here, negative 6x. I write it here. So when you expand, when you take this to expand this, you write the solution under this polynomial. You write it under. So once you expand, the next is to subtract again. We go to subtract again. You keep doing this, expand it, subtract it till you reach the end. Till you reach 0 or till you reach a remainder. Okay, so you subtract again. What are we subtracting? This one minus this one. It will be 0. 2x squared minus 2x squared. It will be 0. So they did write that. Then, but remember this minus and this minus will make this one to be plus. It will be plus 6x. This one will be plus 6x. So it's like you are saying negative 5x plus 6x. That's what you're saying. It will be 1x. You know in math, no need to write 1x. So we just write, we wrote only x. Right? That's why they wrote only x. So negative 5x plus 6x, that's x. It means x. Negative 5x, like you are owing 5 ringgit, $5, and your dad gives you $6. You pay the person you are owing. What remains? You only have $1 left. That's the meaning of this. Okay, so you have 1x. Negative 5x plus. Why is this one plus? Minus times. The only thing left here, you bring the remaining one down. This one. You bring minus 3 down to join the x. You bring this one down. This is a polynomial. You start the process again. You're going to divide this one by what? By x. We only divided by x only. We only divided by x only. Not by x minus 3. You divide. You say x divided by x. You get 1. Because anything divided by itself, you get 1. This x divided by this x, you get 1. That's plus 1. Then you take the 1, the answer you got, plus 1. You use it to multiply what? This one again. Like the same process, we start again. The answer you get, you always use it to expand with this, to multiply this. So 1 times x, we get x. That's how we got this s under. 1 times -3, we get -3. Now we subtract again. We start again the process. We do subtraction, okay? It's laggy, that's why I took a hand. You write, even if it's not written, you get 0. X minus x, you get 0. -3, minus minus become plus. -3 plus 3 becomes 0 also. So this is the end. Once you reach 0 here, or you reach maybe only one single factor, like 2, like 1, a constant, it's a remainder. It's called, that's why we talked about remainders theory also in polynomial. So it means when you divide this polynomial with this small, you will get this polynomial. So your answer is the top, is the one on top. So it means in the end, and then pause it to solve these questions. Pause it GCSE mathematics, because they keep bringing some questions from additional maths to ordinary mathematics. How to divide these division, all this. Please try and solve. Write this one inside, write this one outside, divide this one with this one. It's all the same thing. Solve all of these questions as practice, as exercise. So with this, we've come to the end of our today's class. Thank you for joining us. Theory. Now here, you say if a polynomial p of x is divided by x minus c, if it's divided by x minus c, hence the remainder is p of c. And if a polynomial p of s is divided by as minus b, the remainder will be this b constant divided by this coefficient of x. Okay, now you may not understand this unless we take an example. Let's take an example to show you exactly what we're saying. Okay, here's a question. You say f of x equals to 2x raised to power 3 plus ax squared plus bx plus 15. This is a polynomial that has been given to us. Now, you say when f of x is divided by x minus 1, the question continues. When f of x is divided by x minus 1, the remainder is 5. And when f of x is divided by x minus 4, the remainder is 11. Find the value of a and b. So they're asking us to solve for a and solve for b. So what we do, remember, they said this polynomial, x minus 1, when this whole polynomial is divided by x minus 1, the remainder is 5. So x minus 1 equal to 0, x will be equal to 1. You know, the value of x will be equal to 1, right? If we want to get 0 here. So x will be the value of 1, because 1 minus 1 is 0. X will be 1. So f of x equal to 1. F of 1, substitute it into this function, we get this equation 1. Now, and we equate to the remainder. The remainder is 5. Remainder is what? 5. So we substitute 1 in this first polynomial, and we equate to this remainder 5. We get equation 1. What do we mean by that? Let's take a look at what we're saying. Here, you say 2x. You say 2x cubed plus ax squared plus bx plus 15, right? So when f of x is divided by x minus 1, the remainder is 5. That means f of 1 equal to 5. That means f of 1 is equal to 5. So which means f of 1 means put 1 in place of the whole, anywhere you see s in this function, in this polynomial. So we say 2 times into 1 raised to power 3. 1 raised to power 3 is 1 times 2, we get 2. That's how we got this 2. Then you put 1 here. 1 square is 1. 1 times a, we got a. 1 times b, we get b. Plus 50 equal to 5. Plus 50 equal to 5. So we add the 1 on the left, the numbers on the left. 2 plus 15, we get 17. So we say a plus b on the left. The 17 on the left, we move it to the right. So plus 17, when it comes to the right, becomes negative 17. It becomes 5 minus 17, which gives us negative 12. So we have equation 1. A plus b equal to negative 12. We call it equation 1. Right? We do the same thing we just talked about. We do the same thing. You say when f of x is divided by x minus 4, the remainder is 11. That means f of 4 is 11. So meaning you substitute 4 in place of x in the polynomial, and you will equate it to 11. So you say 2 into 4 raised to power 3. 4 raised to power 3 is 64. Okay, not 12. So people will say, oh, you think it's 4 times 3, that's 12. No. 4 times 4 times 4, 4 in 3 places. 4 times 4, 60. 60 times 4 is 64. 64 multiplied by 2, you get 128. You get 128. Then 4 squared, you get 16. 60 times A, we get 16A. And then 4 times B, because this is 4B. 4 times B and BX. 4 and X is 4. 4B equal to 4B, right? 4 times B is 4B. Plus 50 equal to 11. So you add these numbers on the left. 128 plus 50, we get 143. We get 143. So you write 16A, this 16A, plus this 4B, equal to 11 minus, remember on the left, when you add this and this, you get 123, you get 143. So you say 11 minus 143, you get 11 minus 143, right? When we do 11 minus 143, what do we get? We get negative 132. Now you can see these three numbers can be divided by 4. 63 can be divided by 4, 4 can be divided by 4, 132 can be divided by 4. So if we divide through by 4, we simplify this, we reduce the number because the number is too big to be used for simultaneous equation. Divide here by 4, we get 4a. Divide here by 4, you get only b. Divide negative 132 by 4, you get negative 33. So now you have equation 2. You call it equation 2. 2 unknown. You have 2 unknown. Remember in equation 1, we have 2 unknown, a and b unknown. And then anytime you have 2 unknown and 2 equations, you solve simultaneously. So we bring the 2 equations together. That's what we did here. We bring the 2 equations together. A plus b equals to negative 12, equation 1. 4a plus b equals to negative 33, equation 2. So you say, you make equation 3 by making b the subject. Take a to the left. You say b will be equals to minus 12 minus a. I'm using equation 1 to form equation 3. Okay, by making b the subject. Move a to the right side. So you say b on the left is equal to negative 12 minus a, because when plus a, here is plus a. When it goes to the right side, it becomes minus a. So b equals to negative 12 minus a. We call it equation 3. Now we substitute equation 3 into equation 2. We substitute this equation 3 into equation 2. What do we mean by that? We use 1 to make 3. We substitute 3 into 2. What do we mean by that? Anywhere we see b, because we found the equation for b, anywhere we see b in equation 2, we replace it with negative 12 and minus a. Minus 12 minus a. Instead of writing b, because you say b is equivalent to this, instead of writing b, you replace it with minus 12 minus a. So we substitute now. We write 4a. So instead of writing plus b, I'll write minus 12 minus a, which replace b, equal to negative 33. Collect like terms. 4a minus a, I get 3a. This negative 12, we move it to the right. It becomes minus 33 plus 12. When 12 goes to the right, it becomes plus 12. So I have 3a equals to negative 33 plus 12, which is negative 21. 3 equals to negative 21. Divide both sides by 3, a will be equals to negative 7. So we found a. Now, the next step is to find b. And remember, we already made the equation for b. We say b is equals to negative 12 minus a. So we substitute the value of a minus 7 into a to find b. b equals to negative 12 minus 12 minus a. And remember, a is minus 7. So we place a here minus 7. Remember, you must write the 2 minus. A is already minus 7. Don't write only 1 minus. Don't forget, if you write only 1 minus, you're going to get the wrong answer. That will give you negative 19. That will be the wrong answer. So you put minus 7 here. Minus times minus become plus. That's how this one becomes minus 12 plus 7. So minus 12 plus 7, you get minus 5. So these are the two answers. B, A is equal to negative 7, and B is equals to negative 5. So these are the two answers. Sorry, okay? A is equals to negative 7 and B is equals to negative 5. These are your two answers. Okay, now that's when when they give you factors to find. They put like A here or they put B here. They ask you to find A and B. That's when we do that. But here it's just a simple division. Find in exercise. You pause the video and solve this question. Find in our 4.1 and 4.2. I think we've learned how to divide polynomial. So find the remainder when this polynomial is divided by x plus 1. So first you take this one, you divide it by, you draw something like this. Okay, sorry. You draw something like this. Okay, you put this big polynomial here, x to the power of 3. You put this big polynomial here, x to the power of 3. Okay, I'm not solving, I'm just showing you how to start. So you'll be able to solve this. X to the power of 3 plus 5x squared, 5x squared, 5x squared, minus 17x, minus 17x, minus 21. Okay, this is the polynomial, right? Minus 21. You're going to divide it with this one. Okay, you deal with A first. When you get the answer, the remainder, because they say find the remainder. Okay, when you get the remainder, before you do for B, before you take this and divide with this one, before you take this and divide with this one, they are all separate questions. Okay, so here is x plus 1. Here is x plus 1. We've done this in there, 4.1, 4.1, 4.2, somewhere around there. Okay, so, okay, so you say s to the power of 3 divided by x. You know, here, there's one here, it's lagging, that's why I couldn't write it. Okay, so we say x to the power of 3 divided by x, you get x squared. Now you use that x squared to times this one again. You say s squared times s, you get s to the power of 3. S squared times 1, you get x squared. Then you subtract, like we did in part 1, part A, part 1, part 2. So you do this division, you do this division, you do this division. So that's what you do. You find the remainder, same thing. Then this one is similar to the one we did in 4.5. They give you this polynomial, they give you, it gives a remainder of 7 when divided by this. Find the value of A. So you go to equate it to 7. And by substituting to f of 2, you substitute here. This one is just one simple equation. Why? Because it's not A and B. It's not A and B. And it's not two polynomials. You just substitute 2 into this one. You equate to 7. You find the value of A. Find the value of A. Okay? It's as easy as that. So with this, we come to the end of this class. Thank you for joining us.